So we want to evaluate, in this problem, we want to evaluate the integral over c of x to the fourth y ds, where c is the upper half of the circle x squared plus y squared equals 16. So this is a line integral with respect to arc length, and you have to remember what ds is. ds stands for an infinitesimally small piece of arc length, and the formula for it is the magnitude of r prime of t dt. So you've got to remember what the differential represents. Okay, so the generic formula then, integral over c of little f ds is the integral from, well, a to b if you parameterize it. F in terms of t this time, I'm leaving off the input, and then ds is the magnitude of r prime of t dt. So there's certain things you have to memorize. Make flashcards. This formula is one of them because it tells you what to do. You don't need to memorize step 1, step 2, step 3. Just look at the integral from the inside out. What is the integral on the right there? What does it tell you you need? Well, ultimately, if you look on the inside, it says r prime, right? But if you want to take r prime, you need r. So that's where you start. Oh, good. We get to parameterize another circle. What's the radius on this one? The radius is 4. So what would x be? 4 cosine t, let's say. And then y would be 4 sine t. And if we want the upper half, what is t going to range from? Think of t as an angle here. 0 to pi, yeah. 0 to pi. Now, vector valued function wise, r of t then, let's use alligator brackets. We haven't used that notation today. 4 cosine t, comma 4 sine t, right? Don't be afraid of any of the notation. IJ form, with respect to the integrals, differential form, the other form, don't be afraid of either type of integrals. Just know the formulas, and you'll get more and more comfortable with it the more you practice. Okay, so we have r of t. So look at the inside of the magnitude bars. It tells you to find r prime of t, right? Okay, help me out. What's r prime of t? Negative 4 sine t for the first component. 4 cosine t for the second component. And then what does it say to find? Magnitude. Good old magnitude of r prime of t, which is going to be nice, right? I see a trig identity in your future. So what do you get? 16 t, sine squared t rather, plus 16 cosine squared t. But of course, if you factor out the 16, what's left underneath the radical? Oh, it should be, well, no, okay, you're working ahead. Underneath the radical, what's sine squared? Factor out the 16. What's sine squared plus cosine squared? 1, right? And then, of course, yeah, you get 4 when you take that square root. You don't like showing all that?
No, she's saying the square root is a giant.
That's because I couldn't decide whether or not I was going to write the sine squared t plus the cosine squared t. Right. I lost you. I lost you because the square root is too long? Yep. Okay. All right. So let's go back. All right. Okay. So let's go back up here now, and can you fill in the integral then? So what does this guy become in terms of what we're given here? Remember, you've got to fill in what was here in terms of x in terms of t and y in terms of t. So what do you get? Integral, okay, limits of integration. 0 to pi. X is really what? So it's 4 cosine t to the fourth times y, which is, oh, you know what I need to do? I need to put that, yeah, let me put it on the outside. Okay, yeah, notation's important because when you use bad notation, even if you meant the right thing, you end up getting the wrong answer oftentimes, right? Because you forget what you did in the last step. So that's the x to the fourth, right? Times y, which is just 4 sine of t. Okay. And then so what did the ds turn out to be? Times yet another 4 dt. So that's 4 to the 6th altogether, right? I'm going to just write 4 to the 6th on the outside. Is that okay? You guys see where I'm getting at? Splitting up the exponent here. And then integral 0 to pi. That leaves me with cosine to the 4th t, then sine of t. I'll bet we can use u substitution on that. But this time, what are you going to let u equal?
Cosine t.
Yeah. So u equals cosine t, which means du is... so what do you have to do to make dt, to make a perfect du? What do you need to put in here? Well, we need okay, just think we need a minus sine t, put it in parentheses so it doesn't look like subtraction. Then so you don't change anything, put a minus on the outside. So what is this really? If you don't want to make the substitution, just think of it as u to the 4th du, because that's what this thing is. Right? Okay, so on the outside, we have negative 4 to the 6th. Okay, so what's the integral of u to the 4th? So cosine to the 5th. I'll put the division by 5 out here. 0 to pi. And then what do you get when you take the cosine of pi and take it to the 5th power? It is still negative, right? Yeah. And then what do you get when you plug in the bottom limit? Cosine of 0 is 1. To the 5th power is still 1, right? So minus that. So we get something that's positive, don't we? Altogether, that is. So that's negative. So that's 4 to the 6th over 5 times positive 2, right? What does that turn out to be? 8192 over 5. Do I have independent confirmation of that? Not that I don't trust you. It's the whole mission control thing. Everybody's got to check you. Okay. Oh, you got it right there. Okay.